Hello, this video is a quick overview over the programs that drive the MiniVex robot gripper. Let's start off with an overview. We have the brain, the controller that we'll be using to control the robot. We have three motors down here. One is for the left drive, right drive, and for the gripper, the claw that actually closes around the object. We also have an ultrasonic sensor. Let's start with the sensor. The sensor will detect an object that's close to the robot, and the gripper will automatically close around the object. So it's a small program using the distance sensor. Let's look at our drives. We have the left drive hooked to port 1. We have the right drive to port 6. Oh, and then we have the gripper on port 11. Now, when you look at your robot, you'll realize that the left drive and the right drive are actually mirror images of each other when they're mounted underneath the robot to create the drivetrain. We have used the drivetrain program and we never had to worry about the spin direction of these motors. But in fact, the spin directions for the forward command are going to be in different results or different actions because one motor is opposite to the other. It's turned around and upside down. So in order to have both motors spin forward, when we give the forward instruction, we have to reverse the motor that's backwards, and that is the left drive. So when you click on the gear head, you'll notice that there's a button here that says reverse direction, and notice how the spin goes. So if it's forward, the spin goes counterclockwise this way, and when it spins reverse, it goes clockwise. So we're going to reverse that direction and make the forward direction going clockwise and the reverse going counterclockwise. And the way this motor is positioned, it will actually correspond to this. The wheel will turn forward if you give the forward instruction. The right drive, nothing needs to be changed because it's going in the proper direction. The gripper also has to be reversed because if we give the forward, if we leave it without the reverse direction, the gripper, when it receives the forward instruction, will actually open the claw. And usually we like to say forward to close the claw. So when we click this, it will be exactly that. The claw will close when there's a forward direction. These are smart motors. They have little microprocessors inside of them, so all this is set up by this program right now inside the smart motor. Let's take a look at the brain program. It seems a little overwhelming at first. There are a lot of if decisions to be made. But these are because we're programming the joystick to control the robot, and we have to take care of every position that joystick A, D have to do and can take. We want, for instance, as I mentioned, we want the joystick A for the left motor, D for the right motor, and we want to do things like lazy right turn. If we go up and down on this one, it's going to be a fast right turn, and both up is both forward, both reverse, both reversed, and so forth. So there's a lot of little decisions to be making. If joystick A and joystick D are forward, then drive forward. If joystick A is forward and joystick D is backwards, then make the left motor go forward, make the right motor go backwards, and we do a really quick right-hand turn. And that's the kind of decisions we have there. It looks like a lot. It's actually a lot of instructions, of course, but they're very, very simple. Let's take an example of drive forward. Here we have if controller joystick A position is greater than 20 and controller joystick D position is greater than 20, this means both joystick A and joystick D are forward. Then it broadcasts drive forward. Drive forward is sent to all these sub-programs that we have up here, but only the ones that have drive forward in their programs will respond to it. So right drive, there's our drive forward. When drive forward, spin forward. Left drive, there's our drive forward. When drive forward, spin forward. So both left drive and right drive sub-programs receive the drive forward instruction, and both motors will turn forward and the robot will move. We have reverse, we have left drive only. On the right hand side we have right drive only. Then we have the quick turns at the last instruction, so that when left turn, we spin the right drive motor forward. When right turn, when left turn, you would spin the left drive backwards, and it works very, very well. So as far as the brain's concerned, it takes care of all the possibilities that we can see with the various buttons and joysticks that we have. The last two instructions are quite simple. If controller button R, notice it's the diamond, so it's the right hand button, that's the lower one. If it's down, that means if it's pressed, broadcast grip on. If controller button left side is down, then you broadcast grip off. So if I press the lower right side button, it'll broadcast grip on, and if we go to our gripper program, when grip on, set velocity to 100, spin forward. This other part here is for accidents that might happen or problems. All I want to do is monitor the current, and it says if current is greater than 0.3 amps, shut everything down and play an alarm. So in the strange case that a motor starts overheating or drawing too much current, this will close it down. Now, when you look at this program, it says when grip on, set velocity to 100, so it's very fast, spin forward. Well, if you release the button, then it won't be spinning forward. So how do you overcome that problem? Fortunately, they've done it for you. Look at this side here, when start, this is to initialize this whole system. You set the max power of 50% for the grab, because we're grabbing light objects, we want to save battery power, so we don't want 100% power. This is the interesting instruction over here, set holding to on. That means that when you turn a motor on and you spin it, you can release the button, and the current will be supplied to the motor to keep it on. So if you have the grabber grab something, the grabber will not let go until the motor receives the stop instruction. So it's going to have holding power. It's going to keep whatever object you've grabbed with a simple press of the button, and it will not let go. So how does it let go? When grip off, if you look at the bottom part here, when it receives the message grip off, which happens when? Let's look at the brain program. If controller button left is pressed down, you broadcast grip off. So you press the left button, grip off is sent, grip off is received by the gripper subprogram. You set the velocity to 75 because you don't have to be that fast when you release. You spin in the reverse direction 90 degrees to open up the jaws or the claw, and then you stop the motor. You don't need holding, because once you let it go, it just stays there. It's not actually holding anything with weight. So that works very wonderfully. Let's take a look at the distance sensor. The distance sensor is this. When start, in other words, when the check mark is pressed on the robot, this is a forever loop. If the distance in millimeters is less than 40 millimeters, broadcast grip on. So grip on is broadcast if there's something in front of the robot within 40 millimeters or 4 centimeters, and grip on grips the motor, and it has holding power. So all it has to do is set this instruction, the motor spins, and then it holds, and it will not let go. So that's it in a nutshell. There will be a flowchart being sent to you that has all these decisions and all these paths, and these are actually very simple. You just have to think of all the ways you can turn those buttons and what you want the motor to do. Thank you for watching, and we'll see you in class. We'll have lots of fun. The object is going to be to drive the robot, collect things, but we have to go through a maze, and whoever collects the most things in the least amount of time wins the little competition. See you in class. Have a good day.